Object 268. This Soviet tank destroyer was designed to penetrate heavily armored vehicles, but it never saw combat. In 1956, during tests at a proving ground near Leningrad, a 152mm projectile, weighing nearly 110 pounds, penetrated an armor plate almost 200mm thick. The test results demonstrated the vehicle's potential to destroy heavily armored targets of its time. That is how the story of Object 268 began. It was the last of the Soviet heavy tank destroyers. Despite its firepower, it was never destined to see the battlefield. To understand the origins of this vehicle, the focus must shift to the early 1950s. Intelligence reports indicated that the United States and Great Britain were developing a new generation of heavy tanks with heavily reinforced frontal armor. Standard Soviet anti-tank guns were considered insufficiently effective against these new designs. The Soviet military command recognized the need for a response. The solution was found in increasing the gun caliber. In 1954, a team of designers finalized a new 152mm gun. It fired projectiles with significant kinetic energy, designed to defeat heavily armored targets. However, mounting such a massive weapon on a standard tank turret was impossible due to the severe recoil and structural stress. In 1954, the Soviet Council of Ministers ordered the creation of a dedicated, heavily armored tank destroyer specifically designed to carry this gun. The development task was assigned to Plant 172 in Perm, a facility with extensive experience in producing heavy artillery during the Second World War. The design team selected the chassis of the newest Soviet heavy tank, the T-10, previously known as the IS-8. This vehicle had a heavy-duty hull and suspension, providing enough structural strength to handle the recoil of the 152mm gun. Development of Object 268 proceeded actively. It was designed as a countermeasure against enemy armored units. The hull of the donor tank was left largely unchanged. The designers retained its sloped geometry, ensuring the armor plates remained positioned at highly effective angles. This design helped deflect incoming shells, improving the vehicle's survivability. The main focus was the casemate, which housed the main gun and the crew. It was designed as a natural extension of the hull, maintaining streamlined shapes and effective armor sloping. When the blueprints for Object 268 were presented to the Military Commission, the design drew considerable attention. The frontal armor of the casemate reached 187mm in thickness before factoring in the angle. This sloping turned the vehicle into a highly protected platform. When a shell hit that sloped surface, it had to penetrate more metal compared to flat, vertical armor. The designers calculated the effective thickness of the frontal projection at over 300mm. This made Object 268 highly resistant to many tank guns of its day. The sides of the casemate were protected by 100mm of armor, providing solid side defense. The rear received 50mm of protection, though its primary role as a tank hunter dictated facing the enemy head-on. This tank destroyer was built for frontal engagements and long-range duels. At those distances, its main gun could strike targets early in the engagement, before opponents had time to close the distance for an effective return shot. The upper glacis of the hull was 120mm thick, sloped at 57 degrees from the vertical. The hull sides were shielded by 80mm of armor. The entire steel structure was welded securely to minimize weak spots and maintain structural integrity. The casemate featured a distinct design. While self-propelled guns often had boxy structures prioritizing functionality over aesthetics, the casemate on Object 268 was surprisingly sleek, which was uncharacteristic for a vehicle of this class. The casemate flowed with smooth lines to create a cohesive silhouette. The designers managed to combine effective protection with a streamlined shape. Inside the casemate sat a crew of 4. The driver was positioned up front on the left. To see outside, he had 3 vision blocks. The main periscope was directly in front, while 2 side blocks allowed visibility to the flanks. Visibility was limited, which was typical for closed casemate self-propelled guns, but the layout was optimized to facilitate control over the heavy vehicle. An interesting technical solution was applied to the driver's viewing equipment. A mechanical windshield wiper was installed on the driver's main vision block. An electric motor drove the blade, clearing the glass of dirt, dust, and moisture. This practical detail was intended to maintain driver visibility in combat conditions. The vehicle commander sat on the right side of the casemate under a commander's cupola, equipped with observation gear. He was responsible for spotting targets and coordinating the crew. The gunner was stationed to the left of the main gun, and the loader worked in the rear of the fighting compartment near the ammunition stowage. For accurate long-range shooting, the tank destroyer was equipped with a TKD-09 stereoscopic rangefinder. This optical device pinpointed the distance to the target with high precision. It worked at ranges up to 4,000 meters. The rangefinder tube protruded from the sides of the casemate, giving the vehicle a distinct silhouette. In close quarters combat, at distances up to 900 meters, a telescopic sight was used. It allowed the gunner to quickly lock onto a target and fire. The Object 268 inherited its chassis from the T-10 heavy tank, almost completely unchanged. Each side featured 7 road wheels riding on an individual torsion bar suspension. That gave the vehicle a smooth ride, even across rough terrain. The drive sprockets were mounted at the rear and fitted with special scrapers to shear off caked-on clay. During heavy mud conditions, the mud could easily reach the axles, making those scrapers vital, a key feature of the Object 268 was its gun. The entire vehicle was essentially built around it. The 152mm M64 gun was an advanced artillery design for its time. The barrel alone was nearly 20 feet long. Even stowed for travel, it heavily overhung the front of the hull, giving the vehicle a distinct appearance. The total length of the vehicle, gun forward, reached over 30 feet. This made transporting it and maneuvering in tight spaces a challenge. This firepower compensated for the maneuverability issues. It fired a 107-pound shell at high velocity, capable of penetrating most armor of the era at direct fire ranges. It was designed to counter heavily armored tanks. Its armor-piercing round could penetrate more than 200 millimeters of rolled homogeneous armor from 2,000 meters away. For comparison, the frontal armor on the American M48 Patton was about 110 millimeters thick. The newer M60 was still in development at the time and was slated to get roughly 120 millimeters of armor. The Object 268 was designed with the capability to penetrate these thicknesses. Alongside the armor-piercing rounds, it also carried high-explosive shells designed to destroy fortifications and engage enemy infantry. Fortified firing positions, pillboxes, or heavy stone buildings offered limited protection and could be destroyed by direct hits. The Object 268 could also function as an assault gun to engage enemy defensive lines. The vehicle carried a combat load of 35 two-piece rounds. This meant the projectile and the propellant charge had to be loaded into the breech separately. A setup like this demanded significant physical effort from the loader, who had to work quickly and efficiently under combat conditions. The rate of fire was about 3 to 4 rounds per minute. Gun traverse, however, was heavily restricted. There was a total horizontal arc of 14 degrees, meaning just 7 degrees to either side of the vehicle's center line. If it was necessary to shift fire any more than that, the entire hull had to be traversed. Vertical elevation ranged from -4 to +15 degrees. That was enough to let you engage targets in a depression or hit fortifications on a hillside. Those limited gun angles were the trade-off for mounting a weapon of that size. Fitting a 152mm gun into a fully rotating turret was not technically feasible, as the sheer recoil from firing would have ripped the turret ring apart. Because of that, the designers utilized a fixed casemate structure, sacrificing gun traverse to accommodate the heavy armament. A notable feature was the system for purging the barrel after each shot. Firing left powder gases lingering in the bore, which were blown out the muzzle using compressed air. This prevented toxic fumes from flooding back into the fighting compartment. Inside the sealed space of the casemate, a buildup of these gases was dangerous, risking poisoning the crew or sparking a flash fire. Engineers incorporated a dedicated system to mitigate this risk. Also mounted on the casemate roof was a KPVT anti-aircraft machine gun. It fired a 14.5 mm round. This heavy machine gun was meant for low-altitude air defense. Its armor-piercing rounds could also penetrate lightly armored vehicles. With an effective range reaching out to 1 kilometer, it posed a threat to armored personnel carriers, reconnaissance vehicles, and fortified firing positions. The machine gun had an ammo capacity of 500 rounds in belts. The vehicle commander could fire it remotely, allowing operation without leaving the safety of the casemate. This provided a tactical advantage by protecting the crew from external fire. The fire control system featured multiple sights for different combat conditions. A telescopic sight provided accuracy at medium ranges, while a stereoscopic rangefinder allowed the crew to determine the distance to targets further out. A night sight made it possible to operate after dark. For its time, it was an advanced weapons system. Moving the 55-ton vehicle required a powerful engine. A V12.5 diesel engine was installed in the engine bay of Object 268. This power plant was a further development of the V2 tank diesel used in Soviet armor since World War II. While earlier wartime tanks utilized 500 horsepower engines, this newer version produced 700 horsepower at 2,000 revolutions per minute. It featured a V configuration, with its 12 cylinders set at a 60-degree angle to one another. The 4-stroke design and liquid cooling allowed for consistent operation across various climates, from high-temperature environments to extreme cold. Total displacement sat at almost 40 liters. Fuel consumption was correspondingly high, utilizing nearly a gallon of diesel for every mile traveled. In heavy armor design, power and functional reliability were prioritized over fuel economy. The main internal tanks held over 300 gallons of diesel, providing a cruising range of about 220 miles on paved roads. Off-road, this range dropped significantly due to the higher energy demands of rough terrain. To extend the operational range, external fuel drums were mounted on the rear of the hull and could be jettisoned prior to combat. Back there, you'd also find the traditional Soviet unditching beam, basically a heavy wooden log. Without it, armored vehicles risked getting bogged down in deep mud ruts. The transmission on Object 268 was an advanced Soviet tank design at the time. It featured a hydraulically assisted planetary gearbox, giving the driver 8 forward gears and 2 in reverse. Planetary steering mechanisms allowed the heavy rig to neutral steer, turning in place. That was a critical feature for a self-propelled gun with a limited traverse arc for its main cannon. During trials, the vehicle demonstrated notable performance. Top speed on paved roads reached 30 miles per hour, a substantial statistic for an armored vehicle of that mass. On dirt roads, it maintained a speed of around 15 miles per hour. That was sufficient to keep pace with and support tank columns on the march. A power-to-weight ratio of 14 horsepower per ton provided decent acceleration. The vehicle could climb slopes up to 30 degrees and ford water up to 5 feet deep without preparation. For crossing deeper rivers, it was designed to use a deep-wading snorkel system, allowing it to cross riverbeds at depths of up to 16 feet. Trenches up to 10 feet wide and vertical obstacles up to 3 feet high were within its crossing capabilities. Its dimensions fit within the standard railway loading gauge without needing special permits. The hull was just over 11 feet wide, and a height of about 8 feet provided clearance under the overhead wires of electrified lines. This was a significant advantage, since moving heavy armor long distances under its own power consumed engine hours and fuel. Test crews noted the vehicle's independent torsion bar suspension. The suspension provided enough stability to fire on the move over relatively flat ground. The shock absorbers effectively dampened vibrations and reduced the hull's rocking after taking a shot, decreasing the time needed between follow-up shots. The driver steered using 2 levers, along with throttle and brake pedals. Hydraulic assist reduced the physical effort needed to pull the levers, making the 55-ton machine manageable to drive. The instrument panel included a tachometer, speedometer, oil temperature and pressure gauges, an ammeter, and a voltmeter, allowing the driver to monitor the powertrain's condition. Object 268 was designed to be a heavily armed anti-tank vehicle. It was equipped with a large caliber gun designed to engage tanks at long ranges. Its armor offered substantial protection against many tank guns of the era. The running gear was based on the IS and T-10 series tanks. The self-propelled gun also featured a fire control system with a rangefinder and a night sight. However, the vehicle never entered mass production or active service. During factory trials in 1956, the military commission found several flaws and requested modifications. Issues included inadequate ventilation in the fighting compartment and gun-laying drives jamming in freezing temperatures. There were also questions about the transmission's reliability during extended road marches. The design team worked to resolve these defects, but the modifications required months of additional time. State trials dragged on for several years. Just when it seemed the vehicle was finally ready for active service, new demands and critiques would arise. The military wanted a higher rate of fire. They demanded a larger ammunition capacity and better working conditions for the crew. The engineers made the required design changes. However, every upgrade required more testing, and those tests revealed new problems. The vehicle remained trapped in a continuous loop of revisions. Meanwhile, international tank design was advancing rapidly. Intelligence reports provided new data from across the Atlantic and Europe. In 1960, the Americans adopted a new main battle tank, the M60. This vehicle was equipped with a 105mm British-designed rifled gun that could engage targets at extended ranges. The armor on the M60 was slightly inferior to the protection on Object 268, but this was offset by its high mobility and modern fire control system. The British Chieftain presented another significant challenge. Its development concluded in the early 1960s. The British focused on a 120mm rifled gun and introduced composite armor, which was a major advancement for the time. The Chieftain was capable of accurate fire on the move due to its 2-plane gun stabilizer. The Soviet tank destroyer lacked this technology. In a direct engagement, the British tank could fire 3 to 4 aim shots in the time it took Object 268 to prepare its first. However, Western tank development was not the primary reason for the project's cancellation. The main factor was a significant shift in military doctrine. By the late 1950s, Soviet leadership concluded that a future conflict would likely involve nuclear weapons and be resolved quickly. Large-scale armored engagements were deemed obsolete. Strategic rocket forces took priority, as they could strike targets at intercontinental ranges. Armored forces were relegated to a supporting role, primarily intended to operate in the aftermath of nuclear strikes and secure territory. In this new doctrinal framework, heavy purpose-built tank destroyers lost their relevance. Building expensive self-propelled guns with massive cannons became impractical when anti-tank guided missiles mounted on lighter vehicles could fulfill the same role. The first Soviet guided missile systems were being tested, demonstrating high effectiveness. A missile could cover several kilometers, allowing for highly accurate strikes against enemy armor. Funding for Object 268 gradually decreased. Engineers were reassigned to other projects, and the trials continued largely out of inertia. Military leadership lost interest in the vehicle. By the early 1960s, it became clear that Object 268 would not enter mass production. The single prototype was sent to storage. This marked the end of the era for heavy self-propelled guns designed specifically to destroy enemy armor. Object 268 was the final iteration of a concept that originated during World War II. Its predecessors, such as the SU-152 and ISU-152, were built to counter heavy tanks like the German Tigers and Panthers. However, the age of the heavy tank destroyer had passed, and the class was eventually replaced by vehicles armed with anti-tank guided missiles. Today, the sole surviving Object 268 is kept in a tank museum hangar. It serves as an example of Soviet tank design from that era. Its gun will never fire again, and its tracks will never touch a testing ground. However, even decades later, this vehicle remains a notable piece of military history. It is an armored vehicle of over 50 tons, built for a specific purpose, even if it never saw mass production. If you enjoyed this look at a forgotten experimental tank destroyer, make sure to drop a like. Let me know down in the comments what military vehicles you'd like to see in future episodes, and hit that subscribe button so you won't miss out on more stories about historical armored vehicles. There is a lot more military history coming your way.